This video is all about using the law of sines, and here's the law of sines as we derived it in class. This is the given information, and remember, in order to use the law of sines, you have to have an angle and its corresponding side, which we do. We know angle A and we know side A. That allows us to set up a ratio that we can then turn into a proportion to solve. So if we have little a over sine A, so that of course is 12 over sine 44, we can then use angle B, and that's going to help us find side B. So little b over the sine of 25. Now remember that we're entering in degrees here, so we have to be in degree mode. So I'm just going to cross multiply in order to solve for b. So 12 times sine 25 divided by sine 44. And that tells me that little b is 7.3. So now let's give this a quick draw. So 44 and 25, let's go ahead and find angle C just by using triangle interior angle sum theorem. So 44 plus 25 is 69 minus 180. So we see that angle C is 111 degrees. So this is an obtuse triangle. We'll let 111 be right down there at angle C. And since it says that angle B is pretty small, I just extended that side. There's B at 25. Here's A at 44. Little a is 12. Little b is 7.3. Let's use the law of sines one more time, and let's find little c right up top. I'm going to stick with the same ratio that I started with. That's always the given, and that I would continue to use if possible. So now that we know that angle C is 111, little c over sine of 111, cross multiply and solve for c just like we did previously. So 12 times sine 111, and then divided by the sine of 44 gives us little c as 16.13. And of course, let's go back and be sure our answers make sense based on the information that we know. The greatest angle is going to project the largest side, so 111 projects a side that is 16.13. 25 is the smallest angle, it's projecting the smallest side, and then A, 44, is projecting the medium size. So, looks good, all makes sense. That is a simple example of using the law of sines. Let's do it again. This time, what do we know? We know little a and we know big A. So we're going to do the same thing again, set up our ratio. Little a over sine A equals little b over sine B. This time we have an unknown angle. Think about it. This is an angle side-side scenario. So we are able to set up with the law of sines immediately because we know an angle and its corresponding sides. So this is going to help us here, but we are going to have to use an inverse sine function in order to find the missing angle B. Remember, anytime that we have a missing angle, that is when we're going to utilize the inverse sine function. So I'll show my cross multiplication here. 20 sine B equals 15 times sine 40, divide by 20, divide by 20. Sine B equals all of that. And this is the time to go to your calculator in sine inverse function, and also a good idea to utilize your fraction function here. So focus, there we go. So sine inverse of all of that is going to enable us to find B. So 15 times sine 40 on the top, on the bottom, 20. close those parentheses, we find B to be 28.82. Now, the other reason I know there's only one possible scenario here is that angle A is 40 and little a is 20. Now, if side B is smaller than side A, then angle B has to be smaller than 40. So in this case, angle B is 28.82. And from here, now that we know angle A and angle B, we can very quickly find angle C by using triangle interior angle sum theorem. So that, of course, is 40 plus 28.82. Subtract that from 180, and we get C is 111.18. So angle C is going to be a big, obtuse angle. So we're going to finish this problem off. Now that we know that angle C is 111 and 1800ths degrees, we are going to find side C. Once again, we're going to utilize our given little a and big A to set up our ratio. Once again, slide up here. So 20 over sine 40 equals little c over sine of 100.18. Now, once again, we're expecting side C to be large because it's being projected by the largest angle. In this case, an obtuse angle within the triangle. So cross multiply, solving for C. No inverse here because we're after a side length. So cross multiply, solve for C. So 20 times sine of 111.18, and we will divide that by sine 40 to give us little c equals 29.01. So, which should make sense because little c needs to be bigger than both little a and little b because it's being projected by the largest angle.